Last but not least, this problem reads, how many grams of water would be produced if 20 liters of O2 gas were burned at a temperature of -10 degrees Celsius and a pressure of 1.3 atm? So this problem is a little different than the previous one because it is asking us to determine the mass of water that's produced from a particular volume of gas that is not at STP. So we're actually going to have to start using the ideal gas law to figure out the number of moles of O2 gas, and then after we use the ideal gas law to determine N, then we can convert our number of moles of oxygen to a number of grams of our product water. So let's start out using the ideal gas law. PV equals nRT. And this time we're actually solving for moles. So I'm going to divide by RT on both sides. R and T cancel out, so I have N equals PV over RT. Let's go ahead and plug in some numbers. Our pressure is already in ATMs, so 1.3 ATMs times our volume of 20 liters, 20.0 liters, divided by our gas constant, which is 0.08206, times our temperature, which is -10 degrees Celsius. Now we know that we cannot plug in a temperature in Celsius, particularly one that is negative. So we'll go ahead and take our T value and convert to Kelvin. So -10.0 plus 273 gives us 263 Kelvin. So we'll plug in 263. Now when we solve for our answer here, we get 1.20472. So that is our number of moles of oxygen gas that were burned. Now that we have the number of moles of oxygen gas, we can go ahead and take that number of moles and convert to grams of our other substance, which is water. So we'll go ahead and start with 1.20472 moles of O2. And our first step here will actually be our mole to mole step, so moles of O2 to moles of H2O. And then our next step will be our mole to gram step. So we'll take our moles of H2O and go to grams of H2O. And I know that 1 mole of water is equal to approximately 18 grams of water. Now to get our mole to mole ratio, we are going to have to balance this chemical equation. I'll start by balancing out carbon by putting an 8 in front of CO2, then balancing hydrogen by putting a 9 in front of H2O. Now if I add up my number of oxygens, I get 16 oxygens from the CO2 and 9 oxygens from the H2O for a total of 25 oxygen atoms. Now I cannot balance this equation out with whole numbers. So what I'm going to do is put 12.5 and then fill in my 1. And then what I'll do is go ahead and cross out all my values and double them to get two whole numbers again. So 12.5 times 2 is 25. 8 times 2 is 16, and 9 times 2 is 18. So now I have a correctly balanced equation with all whole number coefficients. So these are the numbers that I'll use for my mole ratio. 18 moles of water can be produced from the reaction of 25 moles of O2. So when we multiply this out, I got 15.6132. We do, of course, need to round to correct sig figs, and actually this time our pressure has the smallest number of sig figs, 1.3 atms. And so we are going to round our final answer to just two significant figures, with that 6 causing the 5 to round up. So this is 16 grams of H2O can be produced from the reaction of 20 liters of O2. Not at STP.